A good lab report or scientific paper will contain one or more setup diagrams. This video will help you make a diagram that helps your readers better understand your experiment. A setup diagram is a simple drawing that shows the important equipment, materials, and measurements that you used in a lab experiment. The diagram is either hand-drawn or created using a simple sketching program. It is used in addition to a setup photo. Here's an example of a setup diagram from one of the experiments used in my physics courses. We'll look at it in more detail throughout this video. A good diagram labels the equipment used and gives an idea how different parts of the equipment are located relative to each other. The diagram also includes important lengths or distances that are denoted by their variables. These can be denoted by a specific number and unit, like 1.0 meters, and/or a variable. For example, if you are measuring the stretch of a spring, you would want to show where that stretch is measured to and from. For a measurement that is changing, use a variable. In this diagram, the stretch is denoted by delta y. For fixed lengths, put in a value along with its unit. In addition to lengths, you should also mark out important positions. Notice that y0 and y are two fixed points, as opposed to the stretch itself, delta y. For my classes, you can always draw a setup diagram using pens, pencils, and paper. This is often the easiest way to do it. Even though I often refer to it as a sketch, don't worry about being overly artistic. You should include a sketch in your lab notebook while doing the experiment. You can simply take a picture of this for the final report. Of course, you might want to draw a fresh version that's a little neater than the one you quickly sketched during your lab time. Alternatively, you can also use a digital drawing platform. The diagram included in this video was drawn using an Apple iPad and an Apple Pencil. I drew it in Microsoft OneNote. You could use any tablet or computer with a pen-based input. After drawing it, I selected the drawing and pasted it into Word as a picture. If you would like a slightly more professional look, you could use a drawing tool. I've created many diagrams using the drawing tools available in Microsoft PowerPoint. I prefer PowerPoint over Word. When I try to draw things in Word, the pieces will often randomly roam around the page. Construct your diagram in PowerPoint, then select it. Paste it into Word as a picture. The advantage of digital drawings is that you can move pieces of the drawing and the labels around without erasing and redrawing. A setup diagram is different from a setup photo. The diagram is either hand-drawn or created using a simple sketching program. In my classes, I ask students to include both a setup photo and a setup diagram. I have found that when students just add labels to a photo, it is often difficult to read the text. This happens when the text and background have similar colors or brightnesses. It can also be difficult to get a good photograph. Sometimes the perspective of your photo can be misleading. In other cases, some equipment might be hidden behind other equipment. With a sketch, you can adjust the location of each piece a bit. You might be asking, why do I even need a diagram? A diagram helps your readers better understand the experiment. You've heard that a picture is worth 1,000 words. Well, there's good reason for that. A diagram helps readers visualize the experiment. The diagram may also help you better understand the experiment. For example, I've had students doing labs on lenses suddenly realize the difference between focal length and image distance when drawing their diagrams. The image is in focus at the image distance, not at the focal length. A good diagram shows your instructor that you understand the experiment. If you have a faulty diagram, that can help your instructor understand your confusion. A good instructor will then help you fix that confusion. Here are some tips for making effective setup diagrams for any science class. First, keep it simple. Use clear and simple lines, labels, and symbols to help convey the information easily. Second, label all components. Label all apparatus, tools, and materials in the diagram with their proper names. Third, show connections. Show connections between the components with clear arrows or lines to indicate the flow of materials, energy, or signals. Use annotations. Add notes or captions to explain the purpose and function of each component in the setup. Make it visually appealing. Use a touch of color or shading to highlight or differentiate different components in the diagram. Check accuracy. Before submitting, check the accuracy of the diagram and make sure it really reflects the experimental setup. And finally, Ask a peer or teacher to review the diagram and provide some constructive feedback to help you make improvements. By following these tips, you can create clear and effective setup diagrams that can help you better understand and explain your experimental setups in your science class. If you haven't done so already, take a look at this playlist of other useful strategies for creating great lab reports.